Go. Okay, so today we're going to talk about metric prefixes and conversions. So the first thing I want you guys to do is in the middle of your page, you're going to draw... Okay, we're going to draw a series of stairs here. Actually, I want to go there, up and there. Okay, and there's four steps up, and there will also be 4 steps down. Or 3, I should say, above the middle one. Okay, this one right here is called the base. This is our base unit. Our base unit, there are 7 base units that we use in the metric system. Okay. However, in chemistry, we tend to focus on 4 of them. They are gram, meter, liter, and to a lesser degree, second. Okay, so it's mass, distance, volume, and time for our base units. Now, this step right here represents 1 gram, 1 meter, 1 liter, or 1 second. Although when we start talking about stuff, we're going to use other values of it, and these values are represented by these prefixes that we're going to talk about. So, base. How do we represent 1 as a power of 10? Like 10 to the x equals 1. What does x equal? Okay, or anything to this power equals 1. 0, right. So this represents the 10 to the 0. Okay, our base unit is the 10. This is not 100. This is 10 to the power 0. Ten to the 0 power is 1. So this is our unit step. As we go up, each time we go up, we're multiplying by a power of 10, or each step up is a power of 10 larger than where we were before. So this is going to be 10 to the first power. We'll be multiplying by 10, and this unit, this is called deca. D-E-C-A. Okay, not desa, deca. It is a hard C, and that represents 10 times. So there are 10 base units in a deca unit. So 10 grams in a decagram, 10 meters in a decameter. Johnny?
Oh, in this packet that we just picked up, it says D-E-K-A.
Yes, that's an alternative spelling for it. Yeah, they're both. That is also okay, and the point to having the K is to emphasize the hard K sound for okay, and the initial for that, the symbol for that is a big D in front of whatever gram. So big D G, big D M is decameter, decagram, decaliter would be with the big D. Okay, next step up, 10 times that is times 100. It would be 10 to the second power, and that is hecto. Okay, these two are lesser used. Okay, hecto, it uses H as its prefix, or as its number. Okay. Yeah? All right. Another step up is going to be 10 to the 3. It's going to be times 1,000. That's right. And this is, you guys should know this one. Yeah, this one's kilo. Okay, and is a K. All right, so if you want to continue with this mnemonic with the staircase thing, you can use this to like how many of these are in those, right? So how many decagrams are in a kilogram? Well, it would be 2 steps, right? You follow me there? You start here. How many? It would be 2 steps to get to kilo. and that would be 10 times 10, right? So there would be 100 then decagrams in a kilogram, because for the 10 times 10, yeah? Or we could go backwards. How many kilograms are in a decagram? And so you would, instead of multiplying by 10, you would be dividing by 10. Yeah? Okay, so we go downstairs, we get smaller. We go upstairs, we get bigger. There are two larger units above, or there's many larger units above kilo, but there's two that we would deal with any frequency here. And each one of them goes up 3 exponents. So we're going to slide up here. Okay, you don't have to, you can just draw them off to the side, but this is kind of how they fit on the scale. As it goes up 3 units, this is going to be 10 to the 6th, okay, because it goes up by 1,000 this time. And a 10 to the 6th, 1,000 times this kilo is mega. Mega is an actual prefix for the metric system, and it means 1 million. Or times 10 to the 6th. Okay. And the next one, and that's big, capital M is its symbol. The next one is capital G. You guys use this one all the time, because you don't actually use the entire prefix. This is you guys know? If you have a flash drive, yeah, it's giga. So if you have a flash drive, it has 16 gigs, right? Gig comes from gigabyte. And that would be 10 to the 9th. And I'm not going to write all 9 zeros. It would be times 1 billion. This is 1 million. This is 1 billion. Okay, or if you're British, it's 1,000 million because, well, anyways, that's not important. Okay, so that's the big size. Okay, question so far? No? All right, now we're going to go small. As we go down, you 10 to the negative first, we're going to have 10 to the negative second, and we're going to have 10 to the negative third. Okay, and these are going to be deci, okay, not to be confused with deca, D-E-C-I, and this is 1/10. So this is going to be times 0.1 of your base. Okay, this is 1/10 of a base, or there are 10 of these in one base unit. Its symbol is D, lowercase d, and so the difference between a deca and a deci is the case of the D. Follow that? Okay. 10 to the negative 2. 10 to the negative 2 is 1/100th. And this one should sound familiar to you guys. This is the centi. And it's times 0.01. Symbol is a C. Next one is milli. Symbol is M. And it's times 0.001, and it's 10 to the negative third. And so those are the little steps going down. These 7 have a mnemonic that I want you guys to at least write down. If you're cool with this and you know this, that's fine. But there's a saying that can remind you what all these are, and it's King. Yeah. King Henry died by drinking chocolate milk. Kilo, hecto, deca, base, deci, centi, milli, right? So King Henry died by drinking chocolate milk. Those are the ones. Okay, the 7 middle ones. So that's how you can remember it. But we're going to go small now. We're going to go really small with the. Okay, so we've got another step down here. Another step down here. It's funny how that like completely fits except for that one square over there. All right. 10 to the negative 6. Oh, get that whole thing in there. 10 to the negative 6 is, let me do this might help us. Okay, 10 to the negative 6 is 1/1,000,000th, and this is one you've heard before too. I'm sure of it. It's micro. That's the actual prefix for 1/1,000,000th, and I'm not going to draw all the zero. Well, I'll do it for this one. And it's 0.000001. That's a 0 point and then another 5 zeros and a 1. I'll only make you write that many zeros a couple times this year. Only a couple. Okay, and the next one is nano. And that is 10 to the negative 9th. And so something, a nanogram is 1/1,000,000,000th of a gram. And it's really small. Okay. So you guys should be able to use this, okay, and count the number of steps that you're using in order to convert from one to another. And if if it's these guys and those guys, your number is going to be really big because these are small units and these are big units. And so you would have, if you chop up something big into little pieces, you're going to have a lot of little pieces, right? Okay, and if you go the other way, it's like how much of a big piece is this thing? Well, that's going to be a really small fraction. Okay, so that's a way to think about it, is the size of the units and how many of those fit into the other thing. Okay, but we're not quite done with this because this works great in single dimension measurements. But if we start talking about things like area, it's a little different, or volume. So if we take an area of, say, 1 decimeter by 1 decimeter, right? So that would be this by that. So we've got this by that when we were talking about our meter stuff. Yeah, that's our decimeter. It's 1/10 of our meter. Okay. The area of this is going to be what? Length times width is 1 what? Yep, 1 decimeter squared, right? Well, that's easy. Thing is, how many square centimeters is this? Okay, we can't just use the fact that there's 10 centimeters in every decimeter and just call this 10 centimeters squared. It doesn't work like that. We have to use each side. So this is actually 10 centimeters. And this is 10 centimeters. And so this is actually 10 by 10 centimeters. So this equals 100 square centimeters. And that's just for area. Because if I take this, and I create a 1 dm, oh, that's just ugly. One dm by 1 dm by 1 dm. Okay, so now we've got a length, width, and a height, right? Yeah? Okay, so the volume of this is going to be 1 by 1 by 1 dm cubed. Can you guys show me a cubic decimeter with your hands? Everyone? Cubic decimeter with your hands? Show me. No, that would be a length of a decimeter. Cubic decimeter. Okay, it was this. You're almost there. You're like one step from being there, Morgan. Okay, remember this? Okay, so it's not just this. It's this thing, right? This is what we used for it. Okay. How much was that? We defined this as being equal to 1 liter. This is 1 liter. Okay. However, each decimeter is how many centimeters again? 10 centimeters. And that's 10 centimeters. And that's 10 centimeters. So 1 decimeter cubed is also equal to how many cubic centimeters? Well, there's 3 tens, so that would be 10 times 10 times 10 is going to give us 1,000. It's 1,000 centimeters cubed. So instead of just being, even though there's only 10 centimeters for every decimeter, we have to account for all 3 directions, all 3 dimensions that we're measuring this thing in, and that cubes the 10. So now we have 1,000 centimeters. Well, that means that if 1 liter equals a decimeter cubed, and 1,000 centimeters, cubic centimeters equals a cubic decimeter, what does 1 centimeter equal? 1 cubic centimeter. If there's 1,000 of these in one of those, then one of these would be equal to 1/1000th of that, right? What is 1/1000th of a liter? Here's our liter. What's 1/1000th of a liter? Milli, right? So 1 cubic centimeter is equal to 1 milliliter. If I were a betting man, I would bet that with the usage of all of these and how similar they are, you might see this again on some assessment or some future assignment where you don't get to look at any notes or anything. Wink, wink, nudge, nudge. I would know these if I were you. Yeah? Okay. Any questions on the metrics and that sort of thing? No? All right, and that's it. And we'll get started on finishing that assignment.